Thank you so much, ma'am, for the kind introduction. A big thanks to the organizing committee of the WeCare conference, the Maharashtra Endocrine Society and Endocrine Society of India. It's a very novel topic today, and we had a good time, Dr. Laxmi and myself, to prepare for this presentation. So together we shall be highlighting on how to read a meta-analysis, because we are coming across so many meta-analysis on different topics, observational, interventional studies. So can we have the slides, please?
So good afternoon. Happy to be here and taking you through the session of applying a systematic review and meta-analysis to clinical decision making. As Sir said, how we will read a systematic review and meta-analysis and apply this in our practice.
So to start with, Dr. Laxmi, how is the systematic review and meta-analysis, how are they similar or different?
So usually people read systematic review and meta-analysis in one breath and confuse it to be the same thing, but actually they're not. A systematic review is a comprehensive and exhaustive review of relevant literature specific to a topic or research question. Same with meta-analysis, but systematic reviews may employ qualitative or quantitative methods in reviewing the question, but as meta-analysis always employs statistical methods with the help of a software, which can be RefMin or R, to quantitatively synthesize the results of pooled studies. So there are various steps in doing a systematic review and meta-analysis, largely the same steps. So the first will be formulating an appropriate research question, then appropriate eligibility criteria, conducting an appropriate search strategy, extraction of relevant results, and quality assessment of included studies, which are the same with both. But then we do a critical appraisal to summarize and interpret the findings in a systematic review. But a meta-analysis and additional data analysis via statistical software that I said, like RefMin, should always be done with a meta-analysis.
Yeah, so in a nutshell, basically, we have been traditionally used to writing narrative reviews on any topic. When we write a narrative review, there's a lot of my choice, my preference, my bias enters into it. So you're reading somebody's perspective. So a systematic review and a meta-analysis is a preset laid down protocols which we are using so that the results can be replicated in our practice. So meta-analysis is a totally quantitative analysis of data coming from randomized control trials, which are considered the highest level of evidence. A systematic review is an even bigger encompass. It obviously has a part of meta-analysis, but it also analyzes data coming from case control studies or observational studies. So it's a bigger way of looking at the larger picture. So as a good thing, because we are talking of replicability. So if you are reading a meta-analysis, if the authors have pre-written a protocol and registered their protocol before actually doing the meta-analysis at the Prospero registration website, that's a sign of a good meta-analysis, because somebody has reviewed it and let it to be published online. Just like when we read a RCT, most journals ask for a CTRI, the clinical trial registration, as a validation of it.
So just a question, sir. So sir has many meta-analysis on randomized control trials and none on observational studies or case control studies. So can we do a meta-analysis on case control studies or observational studies?
Yeah, so I think the right word, as you said in a few slides back, was that if you're talking of observational studies and case control studies, we are doing a systematic review. It would not be called a meta-analysis in the true sense. That can classically be done only for RCTs.
Right. So just to give you an example of a systematic review, this was a systematic review from our own country, Finrenon in diabetic kidney disease. So this looked at various databases. This looked at PubMed and Google Scholar and extracted relevant articles on Finrenon in diabetic kidney disease. Even I can't read these studies, but these were the studies included in this systematic review, and these were the baseline characteristics. And this was a beautiful summary slide which summarized all the studies in this systematic review. So as you can see, there are confirmed benefits, being confirmed benefits, discontinued benefits, and even studies of which results are awaited are analyzed in this. So we have various comparisons of Finrenon versus placebo versus eplerenone, and we have all the outcomes listed here. But there is no pooled outcome from all these trials. But looking at this beautiful figure, we can have a summary on what the studies are being done on Finrenon and also the studies that are ongoing and the results are awaited.
So then we also published a meta-analysis. So meta-analysis, as we said, it's more focused. It just analyzed the data from published RCTs. It doesn't talk of, it excludes all the other forms of studies. So if we are reading a meta-analysis, we should always look for a flowchart like this, because just like we have a checklist to how to do a RCT, we have the Prisma checklist to how to do a meta-analysis. So if a meta-analysis has followed the Prisma checklist, it mandates that authors should be very transparent. How did they go about searching the database? What all the initial number of articles did they search, and how did they come down to the last small, maybe 5 or 10 odd RCTs which were analyzed? A good meta-analysis will always have a flowchart like this. So in this, I think we summarize the key outcomes of the number of main studies, and ultimately our job is, we all love to look at is a beautiful looking forest plots where the key outcomes of your primary and secondary outcomes, here you're talking of maybe the reduction in urine albumin creatinine ratio, the occurrence of hyperkalemia as a side effect. So how do we read forest plots? We shall come to subsequently in detail.
So before we start reading a meta-analysis, just some questions to consider when you're reading a paper on meta-analysis. Did the review address a clearly focused question? Did it include the right type of study? Did it include all the relevant studies? And many other questions which we'll be addressing in the subsequent slides. So sir, I have a question for you. I recently read these RSSDI guidelines where they said hydroxychloroquine at a fixed dose of 400 milligram can be used as an adjunct to diet and exercise in type 2 diabetes, but hydroxychloroquine does not figure on any of the other guidelines. So I have a question for you. Can we use hydroxychloroquine in type 2 diabetes? And if we can use, is it safe to use in type 2 diabetes?
So we are just using it as an example. In your practice, you may come across many issues in your routine. Questions may crop up. So many of us, we don't have the privilege of working in big academic institutes. So at least we can do a meta-analysis if published RCTs are there. That was the goal. So we looked at the data of all the published RCTs regarding the use of hydroxychloroquine in type 2 diabetes. So let me highlight the GIGO principle, which you all hear in computer logic, like the garbage in, garbage out. So if you have analyzing garbage, your results is going to be as bad as that. So meta-analysis can be as good as the quality of RCTs you are taking it. So if the RCTs are not great, then the results, however beautiful and rosy they look, they may not be replicatable in your practice. So let's move ahead to the next slide. So how do we actually, searching is important. The most difficult part is not to miss any RCTs.
So before we go ahead, the timer shows 7 minutes. This is a 30-minute session. I think the timer is set wrong. If you can continue. Thanks. So there are, so to retrieve the articles, it's a long process and a tedious process, but we should be looking at least 3 databases. And Sir and his team have looked at 6 databases in this, more than 6 databases in the study. So I would say it's a good retrieval of articles. So yes to that one. Okay. Not working.
Idea is not to miss. So whenever we do a meta-analysis, always make a team. Because if I do a search, I may miss some RCTs. But if Dr. Laxmi is doing the search independently, she may pick up those articles. The idea is, it's a tedious work, it's a laborious job. You don't want to redo the work just by missing some RCT. So that brings us to after the search, the same flow chart we have already discussed. Next slide, please. Now, Dr. Laxmi, let's look into a simple forest plot. So when we see a forest plot, lot of data, how do we ideally start reading a forest plot?
So a lot of information in this, a wealth of information in just one figure, but we start on the left-hand side. So these are the studies that have been included in this meta-analysis along with the year of publication, the first author and the year of publication. And when we look at the forest plot itself, you can see various diagrams there, some squares and some diamonds. So the squares are representing the mean difference of HbA1c in this forest plot between hydroxychloroquine and the active control group, which are the controls. So you can see the sizes are different of the squares. So some squares are smaller, some squares are bigger. So that means the weightage given by each of these studies to this forest plot. So the bigger the square, the weight of the study is more, and the smaller the square, the weight of the study contributing to this meta-analysis is less. And also the line there is representing the 95% confidence interval. So would you like to add more on what weight are we talking about, sir?
Yeah. So it's not a simple average. Like if you have 10 RCTs, you don't take the average of the mean. It doesn't work like that. So you have a vertical column called weight in the middle, saying 12%, and 3% and so on. That means the final result which you have in the bold below, what is the contribution of that individual paper to that result. So the software recognizes that each study is different. So greater the number of patients, more weightage will be given. Like say the study 3 has 300 patients, it has a big green box. A lot of weight has been given, nearly 16%. But a study with a good number of patients, if the results are really haywire, they have a big standard deviation, so we really don't know whether we will be able to replicate in the real world. So the weightage goes down. So if you look at study 2, to start with, it had only 15 patients. And look at the standard deviation, such a broad, wide line. So the weightage is only 3% to the final result. In spite of the results going haywire, it is talking totally different as compared to all the studies. The software recognizes it and it pretty much ignores it, giving it only 3% weightage. The first study has 50 patients, not a large number of patients, but it got a good 12% weightage simply because it has such a small standard deviation. So that's the beauty of the software. They do everything for us.
So the weight is telling you which studies are good and which studies are contributing and which studies are not contributing, maybe because of the number of subjects they studied, or the confidence interval is large. So when we look at the main result here, highlighted in red, so we have minus 0.17. So this is the difference in HbA1c on subjects who received hydroxychloroquine versus subjects who did not. So HbA1c reduced by minus 0.1%, 0.17. So what is 95% confidence interval? So in the best case scenario, the HbA1c reduction may be up to minus 0.3, but in the worst case scenario, the HbA1c reduction may be only minus 0.04. So
this is the classical case where it is statistically significant, but it may not be clinically significant. So everything we need to take in the clinical context. So if we come further down, we can see some figure here, the black box. So can you please elaborate, what is the black box?
Yeah, so this is a black diamond which is telling us the mean difference between hydroxychloroquine group and control group, and you can see that the diamond is not crossing the line of 0, right? It's on the left side, it favors HCQ, so it is statistically significant if it is not crossing the line of 0 effect. And we can also cross check this by this p-value given here, it is 0.009. So again, it is going with the diamond box and p-value is also significant. So this has a statistically significant result. So, but that's not the end of it. We also need to look at this one. So this is telling us the heterogeneity between studies. So there are two ways to assess heterogeneity. One is the chi-square and the I-square. So here you can see chi-square is 61.24 and the I-square is 89%. So this is a highly heterogeneous meta-analysis, and even though it is significantly reducing HbA1c, these studies are different with regard to their baseline characteristics or the way they assess patients, and this summary should not have been pooled together. So the interpretation is that heterogeneity is high, and therefore you should be interpreting it with caution that maybe this is not replicable in our day-to-day practice.
Very true, absolutely, fully agree with you. So first of all, the reduction in HbA1c was significant statistically, but it may not be meaningful, just 0.1%, right, 0.17%. Add to it, the I-square talks of heterogeneity, meaning all the results of RCTs, how similar are they or how different. Ideally, the I-square should be 0, means all the RCTs are giving similar results. So you are really sure that in your practice also you will get similar results. The other end is I-square is 100, means all the RCTs are talking different languages. So although the final black diamond gives a significance, we really don't know whether we will be able to replicate in our practice. So traditionally, any I-square value of more than 80 is considered very high heterogeneity. Take the result with a pinch of salt. Most likely it will not work out in your practice. If the I-square is between 60 to 80, we call it considerable heterogeneity. 30 to 60% is a moderate heterogeneity. Any I-square value less than 30% is considered low heterogeneity. So whatever result we have got statistically significant, you are likely to replicate in your practice.
But Chitra ma'am is just interested in knowing whether hydroxychloroquine can be used in our practice or not. So based on this graph, what would you tell?
So based on these results, the quality of studies were not great. Why? We shall come to it later. At least from the initial analysis, I think we are not on a strong ground if you really want to use 400 milligrams of hydroxychloroquine for managing diabetes. That's the key message coming from this forest.
So the summary is, don't just look at the p-value. Even if it's significant, it can be heterogeneous and should be taken up with a pinch of salt.
So next part is always look for the grading of evidence of the results of a meta-analysis. So grading is done again by software. You have the gradeprogdt.com. When you have done any software to do your meta-analysis, you can use the R software, which is free. You can use the RevMan software developed by Cochrane Group, that is free. Then there are other paid softwares also. You can just upload it in the Grade Pro GDT and it gives you a beautiful table. So you don't make it by hand. The software does it for you. So here can you just highlight some of the key points of this table? Why this table is so important?
So this is giving us a summary of all the outcomes that have been analyzed. So we have the HbA1c, fasting plasma glucose, postprandial plasma, everything, even the adverse effects, hypoglycemia, weight, everything was reported, which is a good practice to do. Some studies don't report the adverse events and tend to highlight only the positive events. So everything was highlighted here, and we know the relative effect and number of participants in each of the RCTs, and also the grade of evidence is summarized in this. So you have an idea of the whole meta-analysis by this one table, and you can go through it quickly. So I think this is a very good table. And would you like to talk on this risk of bias graph?
Yeah, so the grading you saw 1+, 2+, to 4+. 4+ means very good grade. It's a good data you can replicate in your practice. Anything which is 1+ is extremely low, 2+ is low. So take that result with a pinch of salt. So where did we get this 1+ and 2+? So while putting the grade, website needs information. So it will ask you to put the data on risk of bias. So all meta-analysis will have this colorful graph if they're using the Cochrane methodology. Green means low risk of bias. Yellow means you're not really sure of the risk of bias because the RCTs did not have that information. And the red means there's a high risk of bias. So what are the different risk of bias you are looking into?
So this is a Cochrane checklist for RCTs. There are various parameters that we are looking at. Selection bias, 2 points for selection bias, performance bias, detection bias, attrition bias, number of patients who are not followed up. So up to 15% is acceptable, but more than 15% would be biased. And reporting bias and other biases. So we grade each of these on these points, each of these studies on these points, and come up with a graph like this. So Sir did another risk of bias assessment. Usually we do one. So this was another scale. So what we spoke about earlier was the Cochrane scale, and this is the Gerard scale. So would you like to tell us why you did two scales?
Yeah, because in the previous graph, the Cochrane analysis showed that a lot of studies had a lot of red dots. Ideally, if for a good meta-analysis, they should have only green or maybe yellow dots. If you're having a lot of red dots, the reviewer is going to ask you, are you really sure? So there are different ways of grading. So there's another score called Gerard score. We use that Gerard score to grade, and that also gave us that there's a lot of bias because studies which are losing more than 15% patients in follow-up, that's a high attrition bias. Studies which are not blinding their participants or the person who's reviewing the results, they are again considered two different types of high risk of bias. Studies which involves the pharmaceutical product and one and more authors are a part of that organization or they have funded that study, that comes under the high risk of bias. So it showed that both the methodology when we used, there was a high risk of bias detected in most of the RCTs, and that contributed to the low grade score that we saw in the initial graph.
So there's another bias, publication bias.
Yeah.
So a lot of graphs. Would you like to talk on this?
Yeah. So sorry for the crowded slide. So publication bias talks of like traditionally in medical practice, in medical literature, studies which are reporting good results, they tend to get published more. Studies which are reporting neutral results or they're not working, negative results, they are less likely to be published. So as in nature, everything follows a bell-shaped curve. If something is too good, there has to be something too bad also to follow the law of nature. So publication bias is drawn by the RevMan software, has an option of drawing the funnel plot. And if you select all the studies, you get funnel plot means there's a midline. Some of studies are showing very good results. You'll be having one study showing not so great results. So if you have an inverted pyramid, imaginary inverted pyramid means it has got a low publication bias. Now if you look at some other outcome, for example, and you want most of your studies to be close to midline, that's good. So if you look at this outcome, for example, if you see here, studies are either in the midline and going to the bad side. There is one side. There are no studies on this side. Means for this parameter, only a particular set of outcomes were published in RCT. So this meta-analysis has a high publication bias, and that also bring down the quality of evidence for that outcome, and the grading score will again come down by 1 point. So the software does everything for us. We just need to put the data and just download the graph.
So talking about high heterogeneity, so we did this meta-analysis, free androgen index in women with polycystic ovarian syndrome. So search on PubMed, Scopus, and Web of Sciences, and this is the Prisma flow chart. 24 studies were analyzed, so this is the baseline characteristics of 24 studies. But when we look at the forest plot, though the heterogeneity was high, it was very high, I-square was 96%. So just to give you an example of what we can do if we come across high heterogeneity, so we can do a sensitivity analysis, so we can see if any of these studies individually is contributing to the high heterogeneity. So we did the sensitivity analysis, omitting each study one by one, and still the heterogeneity was very high.
So basically, you actually keep on drawing the forest plot by removing one study one by one, and see whether the I-square is coming down. For here, what you see is that by removing each of the study one by one, the I-square really did not come down when all the studies were going haywire.
So there's another way to look at heterogeneity. We can even subgroup them and do a subgroup analysis by region or by quality of studies, good, poor quality of studies. So even then the heterogeneity was very high. So this means that we cannot really combine, coming to it. He's aware of it, he's aware of it. He was reluctant to put it, but telling you, so this is a very good video. So this is a Meet the Expert session, even for me. I have learned meta-analysis from Sir and his videos. All of you should go through this video. It's a very simple, a very simple way of teaching you how to do meta-analysis. Even I could learn from the videos, so definitely go through it.
Dr. Laxmi, for sharing this. I think it's there online. Anybody who wants to just go through it. If any doubts, I mean, you can write to her, you can write to me. We would be happy to contribute, because as Indians, I think we have so many of us, we can do great things together.
So Chitra ma'am.
It was a wonderful session, and I'm sure there are many questions from the audience.
Do you mean that the entire systematic review and meta-analysis was inconclusive because of the heterogeneity?
Yes, yes.
We cannot make any comment whether free androgen index is relevant or not relevant in PCOS.
From the level of evidence that we have today, yes.
Yeah.
Okay.
It doesn't make sense to do it in a routine practice.
Hi, good afternoon. I'm Dr. Aparna. I'm not an endocrinologist or a diabetologist. I'm a surgeon. But I don't have any question, but I would just like to compliment you on the clarity of the talk. I was just telling Dr. Tejal that I've been wanting to learn this, and it was just, I think, my luck to be here today. So thank you very much.
Thank you, thank you, ma'am.
Aparna is a very well-published author, and she's a member of the Obesity Surgery Society.
I know. I follow you on LinkedIn.
So yeah, you guys need to meet her after the talk. Okay, just one last question. So Dr. Chitra and I, we do a lot of, with Dr. Mahati, we do qualitative work. So is whatever you've taught us in any way amenable to analyzing qualitative research, or can we ask questions like that through this?
Systematic review, definitely. But for a meta-analysis, we would need a quantitative outcome. But a systematic review can definitely be done. Like I said.
So what happens, sorry, because lack of time, we talked of mean differences. And for qualitative data, you may be having answer like yes and no, true or false. There you get the odds ratio. You will still get a forest plot. The software will do it for you.
Okay. So we do mixed methods, right? Quantitative as well as qualitative. So then mixed methods, is it amenable to this?
Yes.
Yes.
So then maybe we can think of working together in future. Thank you so much. It was an amazing lecture. Dr. Chitra has a question.
So when you choose a topic for doing a meta-analysis, is there like a criteria as to the number of studies? Is that something which prevents you from running a meta-analysis on a particular question?
The easiest thing to do is go to PubMed, search that topic. There is a refining search option, click meta-analysis. If somebody has, you get some option, somebody has published it, no point of redoing it. No journal is going to take it unless that's a pretty old meta-analysis, and after that 2 or 3 more RCTs have come and you think the results are going to change, then do it. And then to do a meta-analysis, ideally you need at least 2 RCTs, right? To see the difference. If you need 1 RCT, you have to wait for somebody to publish the other one. And 3 is good to have. At least 2 RCTs you need to do a meta-analysis.
So,
Yeah.
More the merrier, but more means exponentially your work goes up. So you would like to restrict to anything less than 5 RCTs you can manage easily in a month and a half or 2 months. If you more studies means it will more laborious, more hard work.
so the criteria for some of us who've just started out to publish meta-analysis is to Google meta-analysis, Dr. Deep, and see the topic and see if he has already done it, and no, then go ahead.
She's pulling my leg on the stage.
No, we did it, yes.
And we also ran the question by you saying,
Yeah.
do one on this topic.
So that's the first criteria I would say for, right now for us, because he's ahead of time and,
We should ask you, do you charge for doing this so that we start looking for some funds?
No, he doesn't charge as of now, but I think he's thinking about it now.
I'm thinking of having more hands together so that we can do more in lesser amount of time. It's a laborious job at the end of the day.
Have you thought of doing like a workshop where you would exclusively teach us this?
We are happy to do it.
Definitely. And just to add to this, why we should learn this, as Sir himself has told, this is the highest level of evidence. This is even better than doing RCT. So we know it's so difficult to do even an RCT, and this we are combining evidence from different RCTs and giving the highest level of evidence which you can do, sitting at your house. So I think it's wonderful, and everybody should learn it.
Thank you for the opportunity.
Thank you, ma'am.
Thank you for this excellent talk.